righty. Thanks everybody for being here. We're really excited to have Satpal Kaur join us for Reaching Net Zero on the Sea, and to have Bev Craig here to play the role of host again tonight. So Bev, please take it away.
Hi, everybody. Welcome to anybody who's new. Thank you so much for joining us tonight. And I'm pretty sure everything we talk about here on Passive House Accelerator, no one learned in school, right? And I think that means that all of us, we are lifelong learners who are always trying to continuously improve. Does that ring a bell? Yeah. So I was listening this week to a podcast called No Stupid Questions. I don't know if you guys know it. Angela Duxbury, who's a psychologist from University of Chicago, and Stephen Dubner from Freakonomics fame. And the question of the week they were talking about was like, when you're trying to improve yourself, is it better to like lean into your strengths to try and improve more, or to focus sort of on your weaknesses? And I thought it was just a fascinating discussion, honestly, to even think about. You know, when you try something that you haven't ever done before, like a weakness, that first 10 hours you put in, right, leaps and bounds of improvement, right? Just absolutely. But on your strengths, you don't get that same, you know, for every hour amount of improvement, but there's probably a reason it's a strength for you, right? Maybe it's you're naturally really good at it, or you've practiced and you have all this expertise in it, right? Or it really just makes you happy for some reason. So to me, like, it's both, right? We got to focus on continuous improvement and lifelong learning in all of our areas. So toast tonight to Passive House Accelerator and continuous learning. So we are really lucky today to have a super engaging speaker. Satpal Kaur is a high performance building designer, activist, and thought leader, really. She's designed some of the first multifamily passive house projects in New York City, and she was awarded the Building Design and Construction's 40 Under 40 award. Her work really merges building science and environmental justice through architecture, which I think is really exciting. And tonight, Satpal is going to talk about plans to retrofit a very big ship. And I think a lot of us know that embodied carbon is a serious, serious challenge. And we need to start thinking about everything that's built here today and thinking about how we repurpose and change it and upgrade it. So this is a really exciting presentation. Thank you so much, Satpal, for joining us today. We're looking forward to your presentation.
Thank you, and thank you for having me. So let me share my screen first, so you guys see it. So you guys see my screen? Perfect. I'm really excited to share this project and basically be here with you all. And it's one of my favorite projects that I've actually been part of in terms of enclosure thinking, and really kind of was really privileged to think of it in a different way. So before I begin, if I don't know anyone, I really would love to learn about all of you guys soon. And as Bev has already done an intro for me, I feel I have, you know, other than me being a passionate designer, designing energy efficient passive house buildings for over 15 years, I think for me, it is a learning skill. I'm always surprised. I've always liked this idea of continuing to be surprised by my work, have an open mind. And I think that's what makes designing buildings with building science super challenging. And I always say to people, it's like being part of a science experiment. And this particular presentation that I'm going to do today on the sea, I changed the name, is based on the SSUS Ship. It is a study that we did for RXR in collaboration with HLW. Because of the ship's unique typology and the fact it was not on land, but a floating metal structure, keeping itself dry, to me was very exciting. And, you know, having this opportunity to merge naval and traditional architecture to reinvent the ship as a different use, as meeting today's climate needs as well. It was really like an interesting challenge in terms of enclosure thinking and what does it mean? And just really kind of working with the team in terms of, could it be delivered on achieving it to net zero, or what type of things are we looking at it? And surprisingly, I got to work with a lot of the, you know, the pioneers who designed the ship, like Gibbs and Cobbs, etc. And it was really an interesting experience just learning about the skeleton of the ship, which I'll be speaking with today, and just thinking of different typologies for the envelope. And with that, let's begin. So the SSUS ship is a monument, it's an ambassador, and it's the pinnacle of mid-century maritime design and artistic achievement. It's the world's largest ocean liner, smashing transatlantic speed for its time. So it really is quite phenomenal. It's also transformative. It's been a national security asset capable of being transformed again to the state-of-the-art security military vessel as well. So it's a living icon of different stories, which has emerged from the World War II. It's carried people from small towns to big towns, setting out on journeys. And it's also stories about immigrants crossing the sea, beginning new lives. So for the ship, the SSUS ship, it was seemed quite relevant when we were looking at it, for it to be transforming itself yet again. And what really excited me about this particular project, and when we're talking about resiliency, when we're talking about how can we reuse ships in a different way, what if the most advanced building is a ship? Well, how does it, for its time, it had pioneered different type of generation, different generations of systems thinking. Could it still do the same? Reducing its carbon footprint, does it live itself on the ship, or does it be something that's plugged in on site? Is it a destination of the future? What if buildings are not capable of making us future-proof? Do we have to look at other ways that we have to achieve this? So for me, as someone being part of this, like thinking of future-proofing and designing in a very different way, I was really excited to kind of break down what the actual envelope and the skeleton of the ship was. And as we started looking at it, because of its distinctive envelope, we realized that the superstructure plate functions as both the air barrier and a vapor barrier, which is kind of strange because for a metal, you don't normally expect that, but then it makes total sense when you think, oh, of course, there's no water that comes inside the ship when I'm inside the ship, and obviously I'm constantly dry too. But then it does something interesting when the case of the ship in a cold climate, the envelope has to perform to resist the interior airflow that will stop the convective loops that you will see at the bottom and at the sides of the section of the ship itself. And this is because it forms a double hull. And these convective loops, like part of the superstructure, it's not really the wind that's causing it, it's actually just because they're just hollow. So that was really kind of looking at how do we think of it as a retrofit versus like, okay, we're just going to go in and just change the look of the ship because it was an icon, and we didn't really want to do that. And we knew what worked with systems. We knew it needed a complete air barrier, and it had one, technically speaking, because the outside of the superstructure was acting like that. But it also needed to have some form of compartmentalization, which we know also helps in terms of performance. So taking these, and it would also reduce the convective loops that was happening alongside these, the actual hull of skin of the ship as well. So we started digging down further into the actual ship and how it was generally constructed, because we needed to obviously place a lot of systems, we needed to insulate it. And how do we do that? Because we were also lacking height. We didn't have much height to run a lot of ductwork, and we definitely didn't want to reduce interior space as well. So as we started looking at the ship, it actually consists of this series of bulkheads, and they serve as a way of if there's ever a water, if there was any kind of water that would enter, it would just like drop down, as you see over here, and they would just prevent water going from the next to the next compartments. So there were 20 watertight compartments, and out of the 20 watertight compartments, you had 8 of these bulkheads. But what I saw in this was more than that. And this is right at the beginning. What I saw instead was, wow, these are these hollow spaces. This is great. This is what I need. And I need this to run systems. And what happens is from the whole deck, so it's no longer first floor, second floor, third floor, the language completely changes. So you have to speak the language, what the ship is. So in this case, in the hold, you have this the double hull. And then once you get to the B deck, which is like above, now you're kind of emerging out of water itself, just about here, the double hull actually changes. And I'll show you what I mean by that. So this is a section cut. So these are the series of the structural grid of the existing ship that runs continuously, which acts as, we would say, to some degree, compartmentalization, the watertight bulkheads, etc. But what happens is it goes from being 9 inches all the way from the hold to sea deck, and then it becomes 6 inches and then smaller. And that was the opportunity that we needed really to run a lot of these systems that we were thinking, obviously not from the bottom, but could we use this double hull frame as we're retrofitting it to run a lot electrical, the mechanical, and even the insulation? Like, how could we utilize the space, which is not really being used, but we, reinventing this whole thing about what is this space going to be? And so in terms of, so we firstly looked at ways existing ships were doing compartmentalization, because some of the programming of the space meant that we had to look at our space differently too. And just with buildings, I was seeing a very similar language, how we would say, for example, you would have the unconditioned space where you would run a lot of the mechanical systems, and obviously above you'll have a lot of the conditioned spaces running. And this is how they pretty much do it in the marine naval world right now. And it works. It's actually kind of interesting how they look at this as a division of main vertical zones by thermal and structural boundaries, of obviously fire risk categorizations that they have. And for the ship, because it was going to be a building, we had to translate it into the building world. And because we were translating it to the building world, we decided it was going to be, at the time, what was the code thing? It was type 1 that it fell into. And because of that, we could, if we wanted to go like construct as high as we needed. But what we identified instead is we were going to use the existing bulkheads that they have, which have highlighted in the dark red, and we were going to run them all the way through down to the actual hold itself. And these will act as the 4 compartments that would actually form as compartmentalization instead. And that kind of helped in us, like how we were thinking about the systems in general. Oops, sorry, that was too fast. So that helped in terms of what we were thinking where the systems would be running, because in the same way we had compartment A, B, C, that would be the same way we'd have electrical, mechanical, like all of these would have their own electrical, mechanical, etc. in these same compartments. So it wouldn't be, there would be a crossover, etc. And then with the existing installation that they have for new ships, is actually fairly interesting. So they have, what they use is an A60 marine board, and they pretty much use what we would say, just put that envelope, just cover it with every, this would technically, I guess, be your thermal, fire rating, everything mineral, that they would just follow the whole structure around it, cover it up for fire, cover it up for thermal, and then they would run anything that's needed. And to me, this was great. However, because our ship was old, we couldn't really technically do as much of the things that the new ships would, because we would obviously be applying a lot of fireproofing on it and then working backwards from all that. So it was then we were back at the board and looking at it in a very different way again. But this helped in the sense what we could achieve looking at the technologies that they already had. So with the idealized enclosure that we kind of already know that forms a good performance in a wall is when you start having, you have the finished layer outside, try to have your thermal layer on the outside, and then have your air control and vapor, etc., just before that structure, just because you can control a lot of things. In the case of the ship, everything changed because here we had that red line was basically the outside of the ship itself, which was my air and my air control layer, and that had to be super tight. And in the case of the ship, it has these series of flaps, which I'll show on later in the sections, and they had to also be airtight as well. So we had, the way we were thinking of it, because we wanted to run the systems in this double hull, we were like, okay, so we will kind of do that, the smart vapor wall system here and just try and, calculate it and make sure it everything is going to be performing as we would do with any kind of high performance building. And this was a section that I had to take to, at the time, to RXR to basically convince them they needed to do this. And I was super nervous because I had never had done a ship before, but I knew how to design, obviously, high performing buildings, and I knew how to make them work. So I was like, I'm going to use that same strategy on a ship. So what do I have? I've got nothing to lose, so I might as well go with it. And so I did the enclosure line, just showing them, we're going to run the insulation just as you would do, but this is obviously a retrofit, you know, running inside of the double holes. And then we would compartmentalize each of these spaces on the left-hand side and the right-hand side for whatever purposes or the programming would be. And because I'm a huge fan of a unitized system, my first proposal was like, why don't we have a unitized system? Therefore, the ship can potentially, you know, we don't have to introduce so many systems for it to be relying on huge mechanical work, etc. They were obviously not a fond of that because there would be holes introduced, but you know, so we went back, but you can see there's a way of running a lot of these things on the inside and then along the actual, the double hull itself. And this is the same way that it would be same in, you know, in any kind of high performance buildings. You have the ERV just going straight out, and then you'll have the heat pumps doing their work. So we formed a hybrid in the next one, which is basically, we decided to go with the air source heat pump instead, and everything, just including the mechanical, the electrical, all of the systems would run on the outside skin of the double hull itself. And instead of like actually living on the ship, we would actually have it plug into the main land. So a small building would be produced for that. So you would have, for the most part, the building will be able to, oops, why does my mouse, sorry, keep doing that. For the most part, the building will be able to work by itself. And this was a success for a variety of reasons, because it meant that we could do the installation, we could run the systems, we wouldn't reduce, there will be no head. Sorry, can you hear me? Sorry. So you wouldn't actually lose any of the headroom as well. So with this thinking, we actually moved forward with the ship thinking how to design for it. And so that's the plug. It will be plugging in back to some of the mainland, but most of the generation, most of the electrical, plumbing, etc., would just be we would have a vacuum system that would actually get the toilets, etc. So most of this I can only show big picture wise because we're still in the process of finishing most of this off. But when it came to the enclosure, we had 3 different ways of looking at the enclosure of the ship. And this is one of the plans, and they all changed because obviously the nature of the ship is that the enclosure is not like a wall, it's not straight everywhere, it's going to change. And because it changes at the bottom of the hull itself, we actually, the first one that we had, the baseline approach, we are pretty much following what they would normally have done. So because the double hull is quite thick, we would actually say, okay, fill it up with some kind of stone or water, whatever you need it, because the ship needs to like balance itself. And then on the outside, they will just have the same spray foam. And then after the spray foam, closed cell insulation, the air gap, green grit thermally broken clips holding the mineral wool, which is very common in ships that they use, and staggering it, and then forming another air gap and running then the final finish coat. In the number 2, the ones that you see over here running instead, what we proposed was different. We said, okay, for this one, can we just not use a continuous marine grade coating, which they use anyway, which serves the whole fire coating, which serves as an air barrier at the same time. And let's just run that all the way from the second steel plate instead. And we just did everything using mineral wool. We didn't actually introduce spray foam at all. And instead, for the smart vapor barrier, we proposed this with this green line that you see over here, We actually proposed a quad 0 NL instead, and then again, the air gap and so forth. For the last one, the alt 2, what we decided was that since the ship's unique nature of the curvature, could we just potentially just, we have the technology now, can we just not 3D scan this thing and the final enclosure is just put on? Like we just use a series of slots, they just get, introduced and that's it. And it's actually not as simple as I would love to say, because it obviously becomes a much more of an expensive project, but definitely an interesting one. And then when you come up towards the higher decks, which is the promenade deck and the sports deck, the ship is no longer as part of the double hull system. And you can see this in plan now, where it's actually offset from the deck itself. From the hull itself. And the way we had to think about that was literally like a building. It had to be, you're going to be putting a building on there. So how do you make that building airtight? And that to me was fascinating, because that would be this whole floor from basically promenade deck onwards, it would just be compartmentalized altogether. So the floor below that would actually act as its own volume, and then the floors above would become its own conditioned space. These are some therm studies that we had done when we were looking at understanding how the ship is performing. And obviously, it would be cold because it's metal. And when you add insulation, it starts behaving better, which we all have known, but it's good to see that still. And so it allows us to understand where we could improve and how we can design differently with the ship. And this is a section of that therm as well, where we get to see that cold and hot spots. So obviously we have some thermal bridging happening there. How to again, putting it back there, understanding it better. These MEP things would no longer run here. They would pretty much run in this space over here instead. And one of the things which, as any designers with a ship of this nature, they really wanted to embrace the whole ribs that the ship had. So with the main hull, we, expressing the ribs became part of the design thinking too, then therefore it became part of the enclosure thinking. And kind of how do you make this system still work when you want to make it high performing, when you want it to reach a net zero, when we're trying to not be wasteful with a lot of things around us. And it really meant for something like this, we had to go back to that whole 3D fabrication system just because of the nature of the shape of the ship. And we continued with the same thing, saying, hey, okay, it has its air barrier. Over here, it has a series of laps, and then each lap, as the ship is made, they'll just get a series of air seal done on it, so it's completely tight. And then after that, we'll do the whole fireproofing, and then the spray foam, and put a foam blocks around the windows here. And this is a section of, a plan and a section showing this. So that's pretty much big picture wise what we try to do in a very intense period just before COVID. And it was a lot of work, a lot of scrambling. And one of the things that was interesting, just when I was saying just about when you get to the promenade deck, things change. And one of the exciting things that we got to do with this was, okay, so the king post, which is very much part of the ship and the way people are seeing the ships, could we reuse these king posts? And I'm a huge fan of reusing pretty much anything a designer can do. So with this, I had to do a lot of convincing, because I was like, why can't we just not run a lot of the ERVs through our king post, because it doesn't serve anything. It's just there. It's not really doing much. I mean, we used it for structural reasons in terms of putting out a cable support system. So it kind of looks like the whole ship is coming out. And we wanted to kind of be more part of its history, to be technologically forward thinking, really embracing that. So I propose, let's just go all the way. Let's run the ERVs running through this, the king post that we have. One will be the return, one will be the supplies. This particular programming space that we had designed, I said, is capable of having the air source, small heat pumps actually being part of the roof. Let's design a different type of roof where the air source heat pumps can sit on the roof and we can vent it out. It doesn't have to be something that's treated as separately. And that to me was really exciting, because all this would be obviously coming in, being prefabricated elsewhere, and just basically being put onto the ship itself. And it was these systems that a lot of people, especially with air source heat pumps now becoming more available, it was a lot of just investigating what is the smallest size we can get. How do we get this looking as minimum as possible? How does it fall with the aesthetics of the design and still be revolutionary in what the history of the ship is? So that was the actual promenade deck itself up that we got to propose this for. And then this is how it would be if you wanted to ever get married or redo your vows. This is how it would look from the inside. So these will be your king pose, and this will be the time you actually take your vows and have that perfect time. Oops, that's too fast. So one of the iconic things about a lot of these ships, especially the older ones, this is a lifeboats of these ships, and they're amazing. Unfortunately, they are there, but they're not usable. And I really was interested in creating a very different way of looking at this with our team. And so we kind of saw it as a car technology instead, where you will still, be able to enter these series of lifeboats, but a different type of experience. And what we proposed instead is it will keep the same kind of square footage of the existing lifeboat, and you'll be able to accent them from the promenade deck, which are these over here, and you'll just enter straight in. And it has, again, the same principles of any high performance building, where we would run just like any car. You would have that whole, insulated shell, but this would just have that shiny metal stuff, and it just be something that just comes on. So you'll have the enclosure with the insulation and then the whole air barrier system, and we would run majority of the systems, at least for the plumbing, etc., would run here, and for the ERVs would actually host them there, and we would just vent them straight up from the from the top of the cabana itself. And this is a view of the going towards that, so you kind of get to experience as new and old, and you still get to have the structural being intact. And this is a view from the inside. So even though you may not have the old boat, you still have the experience of, even the experience of the old boat, you have the experience of the new version of it. And so one of the things I liked about this particular project was, and I realized as I was working on it, it really was a retrofit, and it didn't really occur to me as I was working on it, because a ship it just seemed like a ship, but I guess, it is a retrofit project. So one of the things I find interesting when I look back at this, can buildings be done like this when we're thinking about resiliencies? Are there other objects other than buildings that can still form this? And because it seems as though it's doable, we have the technology now, we have different ways of thinking about it. And as flood levels continue to increase, like what are the different typologies that we're putting out there, which might not be normally that are considered buildings, and they become buildings? And this was one of them. And I'm super excited to see what are the next steps for this. So we'll see. And so far, this is where we are as we just hold tight with COVID. But thank you so much.
Excellent stuff, Sapal. And Zach, we'll go to you first.
All right, great. Let's see here. Great, Paul, this is amazing. I'm looking forward to the questions. Before we get there, I want to thank the organizations that help make everything happen for us here at the Passive House Accelerator. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Thank you also to our champion sponsors, Icon Windows and Doors and SIGA, and to our stakeholder partner, the New York State Energy Research and Development Authority, NYSERDA. Thanks also to our patron sponsors, Aero Aggregates, Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Euroline Windows, Innotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So thank you, sponsors.
Thanks, Zach. Let's get into the questions. We got a few lists here, so we're going to go Jeff Rudine, John Brule, and Kim Brennan. So Jeff, you get to start, my friend.
So thermal bridging is what's top of my mind when I look at a steel hull connected to more steel, connected to more steel. It must have been, I'm just curious.
It was crazy. It was a huge, another learning education trip, especially learning from, the marine world is doing such a great job. In fact, I would say they probably were employing already the building science concepts before we were doing it in our building, sadly. But it was a lot of rethinking about the work that I was doing. And obviously I was having my own heart attacks because I was like, there's just metal after metal, and how do you kind of prevent not hitting dew points as well, etc. So it was a lot of therm studies, and it still will be still a continuing ongoing study because of the nature of this particular project. I think you can get away with certain things because technically speaking, most of us have been inside ships. They're not uncomfortable. They're pretty comfortable. It's just I think it's just that whole thing. Just you have to be rigorous with this detailing. It's just these laps. There's so many of them. There's just so many of these metalwork that they have. It's just doing a retrofit is full of this, something of this sort is just a different life. It's not a brand new ship where you can potentially get it perfect. This one would be a labor of love, I would say. You would have to dedicate pretty much most of your life just doing it.
So this is a little bit on a different topic, but I was also thinking on the supply side of the equation, which these ships typically run on the most dirty fuel that can be imagined. It's like what, #1 bunker oil? I mean, it's like close to sludge. It's
right. And that was the reason why I was adamant when we were included to be part of the team. I was like, we need to make this ship net zero. It has to be part of that thinking where we just cannot, well, firstly, we couldn't introduce gas anyway, so that was great. So it worked in our favor. So it was just putting back a lot of the systems and how the systems could be placed, and with the whole, I can't say too much about the programming, but just generally it had, with restaurants, etc., like there's a lot of humidity, there's a lot of people, there's a lot of cooking, like how does it still serve that? And surprisingly, it wasn't as bad as I thought. And I think the reasoning is because the ship itself doesn't suffer the same things as a skyscraper does. Like it's not all glass, for example. It is tin, it is metal for sure, but it was just kind of running a lot of these systems and making sure that they can go back and there's one in New York City right now, I think is Intrepid. And it's kind of taking that similar concept where, and similar to Intrepid, it has its base building of systems that it connects to. This would be the similar concept that we were adopting with this. And similarly with the shed, for example, the shed can, in New York City, the architecture of the shed, it can move around where you have these sprinkler pipes that, can attach and detach, taking that technology of knowing where things can attach and detach accordingly. So the team that we were working with in terms of mechanical systems, they were super cooperative. They took a lot of my crazy ideas and they were willing to entertain them. So I appreciate that.
Open minds are always wonderful to work with.
Yes.
Great, Jeff. Thanks for that question. And we're going to head over across the pond over to John. John, how's your
Hey guys, I've missed you the last month or so. Good to see everybody, and wish you all a Merry Christmas. I think we had Christmas before you, so we're lucky. And the New Year. Great presentation and amazing project. Really quite amazing. Moisture control. how have you dealt with that? Obviously, there's no breathing happening within the fabric, and also wondering what you're doing with glazing for those windows, whether they're fixed windows or opening, and how the PHPP handle all of those things.
Yeah, so the windows will be operable, just to, give that same experience that it had before. They are difficult to obviously get it to perform and make it really super tight. And I think one of the realizations that I've had for this particular project is that you would probably have to produce something unique for this particular project for it to really be successful, because that's our weakest element right now, because we're connecting back to, usually they were on the surface of the hull, of the double hull itself. And in this instance, I think what we might end up doing is pushing them out slightly, and just working with it differently like that. In terms of moisture, good question. There's a lot of it, making that kind of a balance. We're still trying to figure out the best way to work with that. In sense of compartmentalization has helped in terms of breaking out, so it's not just everywhere. And also just generally because of the ship's character, it's just kind of making it work to meet the net zero. I think that's the reasoning, and just kind of applying that smart wall system type back to the wall, to the ship's hull that we would have applied to any retrofit. I think that's kind of been interesting because it has its own levels of halfway being in water, then being above water, and then obviously you're completely above, and then you're exposed to the elements, etc. And I think that study has definitely shown, at least to our team, that it is something that we have to, at least for the part underneath, we have to kind of look at different ways and different technologies, how the moisture is moving around there, especially for the kitchen elements as well, because that's a lot of steam, etc., that they have. So I think right now the way, hypothetically would be just to probably take a lot of the way the existing skin of the hull is, where the lap system that I was talking about. We get innovative how you introduce ventilation in some parts so it's not disruptive to the character of the skin. That's like one way of looking at it. But right now we're just looking at these in studies, so hopefully I'll have more to share with you soon.
Thank you. Fabulous. I don't know how you get a client who decides they want to make their ship a passive house. That's great.
Well, I was surprised they actually decided to go with it, to be honest with you. But I really commend them for it, because I feel if they do this, they would be obviously one of the first to really make this work and work successfully. And it definitely has a lot of potential. And being a technology of this sort that this ship has a history for, it's definitely a game changer.
Good luck. Fantastic. Thank you.
Thank you.
I think the next questionnaire, Kevin's left. And so his question was, where were they planning to have it docked?
I cannot say.
No problem. I knew there was one of those ones of just, again, looking at the whole process of it. Shannon, you're up next.
Hey, thanks, Sean. Satpal, it was such a wonderful presentation. I really like the way you share your process, and let everybody into kind of what you're thinking as it's unfolding, because I've never seen anything like it before, and it sounds like you hadn't either. So I missed the beginning, and I'm wondering, how did the project come about, and how long did the design process take you, given that it was so new, or at least take you until now, to where you are at the moment?
Sure. So we actually came about as a study. We were invited to do this study. Well, the firm that I was part of, they were invited to be part of the study. And then I was like, I would love to be part of the study because I'm a geek and I want to make this ship the best ship in the world. And so I imposed myself part of the team, basically. And it seemed to work well. But realistically speaking, it's because I really wanted to produce a different type of retrofit, and the RXR were really open towards new technologies and new ways of looking. And the SSUS Conservatory right now, they're trying to, renovate, and basically bring this ship back to life in some sort. And I felt it would be an injustice for it to bring it just back to life. I thought it needed a bit more than that. It needed to be, and I think this, Shannon, about myself, that I feel it needs to speak to the current times that we're in, and it needed to really be part of this, what we, in terms of climate change as well. And they were totally responsive, and that was where the whole journey began. And I was surprised this whole double hull skin thing, no one really saw it. And then maybe because I was spending too much time thinking about retrofits, that was like my first go-to. And I was terrified to present the idea because I felt people would just think I'm being crazy, because normally they run systems on the inside, not in the skin of the, of the ship. But they did. There was a lot of embracing of different and new technologies, and that's what made the project really unique. And I think it meant just really kind of looking back at the research and what was available there, and speaking a lot to the marine architects who were already doing this and understanding what type of techniques they have, and even speaking to other building scientists, even like John Straw, when I was first started on this project, because I was like, how do I make this ship work? Because I'm panicking at this point. And he was like, you're fine. It has already an air barrier. And it just didn't occur to me. It already had an air barrier.
Of course. Yeah.
But it's definitely an interesting project. And I really hope over time they go ahead and, make this a realization as well.
Yeah, me too. I would love to see kind of the monitoring and commissioning.
Definitely. Yeah, I feel like it's definitely embraces a lot of the work that we do in the Passive House Accelerator, like forward thinking, applying different systems. And I think that's the need that the ship really needs with its current in the way it is. It cannot really use traditional methods as much.
Oh, can I ask you a question about the electrical systems? And maybe forgive me if you went over this, but do they have more DC, AC, or is there a good combination on a ship?
I can't remember. I'm gonna have to look that up. I think there might have been a good combo. I'm gonna have to look at that. I think
always DC.
Yeah, we had a presentation last night about DC microgrids and how much more efficient they are. And I was thinking, well, if you're on a ship, efficiency is really important, right? And having power on the ship is pretty important. So maybe it's all DC.
I can't remember what the electrical engineer proposed, to be honest with you. I don't even think we got to that nitty gritty actually, because we were too busy trying to just convince them the systems need to be made.
Well, it's brilliant. And I'm glad you asked the questions and that you weren't too afraid to give them your ideas, because they were good ones. And obviously they were accepted. So bravo, well done.
Thank you, Shannon. Appreciate it.
Thanks, Shannon. Always enjoy the questions you have. Over to Brian. Brian, you still with us? Just go look now. Brian had. So we'll move over to Scott Kennedy.
You caught me sleeping there.
Hey, it's a long day, buddy. I know.
I was just curious, as when we talk about it as a net zero project, what was the energy source that you're citing as the energy source to make it net zero?
What is the energy source? I think in this one, when we're citing it as net zero, it was really I'll be honest, it was very much in the broad sense. And, could it be off the grid? Does it have to be something that's reliable to the city, for example? And it wasn't really looking at much of recyclable materials yet or anything like that. We were really kind of making sure the ship itself could sustain itself, quite frankly. That's pretty much how we approached it. And we haven't really got to we haven't even got to the point, does it need solar panels? Would it need solar panels? How much, all this other stuff that, in order to offload, etc. we haven't even got to that, because that would probably lead to another discussion of, oh, where do we place these? How does that help the ship, etc. So I think when we were speaking about it in net zero, trying to get it to net zero, the main thing was, how does it sustain itself? Like, how can it take less from the city and just reuse a lot of the loads that it has itself? And I think that was like pretty much a very basic way we approached it. And it was also not to get too carried away about a lot of the other big stuff, just because the first concept of this was to get a lot of buy-off, to say, okay, we can do this. So there was a lot of number crunching, how much, how tight can how small can we get these air source heat pumps to serve a lot of these people, and where can it sit? Because the ship has also these huge tunnels that, kind of form there. And they became architectural representation, and nobody wanted to place any mechanical stuff in there. And so that was a reasoning why the ship itself would have a separate building, because a lot of the ship kind of becomes architectural itself. So right now, the way it's being approached, which is obviously in its first phase, is just going ahead and saying, okay, we're going to try and get it not take as much as, power as it normally would have been, and just it's sustaining itself, because it's not taking gas. Everything is going to be based on electric. We're taking the minimum that's required of any type of building of its size. And that's it. Nothing has been even looked about how can we introduce any kind of different form, which I'm sure would be like phase 2 when that is introduced. But the reality of this ship is it needs to be cleaned up. There's a lot of it that probably potentially cannot really be saved, I think. I think just kind of knowing that it's working with, you're keeping most of this intact, and how do you work with something that, where do you keep it intact and what you don't? So the answer to that is a very basic one. Just keeping it minimum for now. It's nothing fancy, I'm sorry.
Okay, thanks.
Thanks, Scott. Zach, over to you.
Yeah, great. Thank you. So maybe phase 1 is net zero ready, and we'll see what happens with phase 2. Yeah, so we are wrapping up our programming for 2021 tonight in terms of live programs. We're going to take 3 weeks off during the break. We will, however, be doing the podcast throughout this time. So you can, if you start to miss us, you can load up your podcast and listen. There will be a new episode each week. The most recent new episode is an interview that I had the chance of doing with my good friend Skylar Swinford of Energy Systems Consultants. He talks about his own house, his SSUS Passive House that he just completed in Boise, Idaho, as well as the work of Saul Griffith around electrification, electrify everything, and the role that Passive House can play in helping to accelerate the transition toward clean energy on the grid. So really fun conversation. Skylar's a super smart person, so please enjoy that podcast. We're also near the end of our bonus episodes from the FIASCon conference in Tarrytown, and the most recent episode features a brief interview that I had the chance of conducting with John Wolfling of Datner Architects about this massive affordable passive house project going on in New York right now. So John is doing some really inspirational work, and you can catch up with that conversation on the bonus episode. And then, as I mentioned, we're taking a little break, but we'll be back for the showcase on January 12th. We'll be back for Construction Tech on January 11th. The January 12th episode of the Global Passive House Showcase will kick off 2022 with a presentation called Decarbonized Homes, Healthier Communities. This is a report based on an RMI, Rocky Mountain Institute report, written by Bomi Jung and Yuan Tan, and they will be here with us to describe what that report was about and the importance of both building or beneficial electrification and passive house in delivering a just climate action in buildings. So really looking forward to that. And I think that's it for me. Thanks.
Thanks, Zach. Over to you, Bev, for some final words before we turn over to the after hour.
Yeah, well, South Paul, this is amazing. Like really, like, which I gotta say, like, we all need to think outside the box. We just do. And this idea of things that have a lot of embodied carbon in them, we got to figure out how to use them a different way.
Yeah, I think that's pretty much was my takeaway with this particular project, that you can pretty much do it. It's just sometimes we don't realize it might be there. I think I would say buildings is great, but maybe if you have something like a floating around, like a boat no one's using, it has the potential. I mean, clearly it was, keeping us watertight at some point.
Well, thank you so much for joining us today. You give us a lot to think about. So everyone have a nice break. And we're going to stay on, right? Zach, for the diehards who have more questions, I've got to say, South Paul is doing so much prototype cool work. If you want to hear about some of the other stuff, maybe we can get her to show us a little bit.
Oh, I do have some news to share though, before everyone parts. And I just found this news today. So those who know me, and they know that the type of work that I do. So I today finally got a home for my PIA project. So I'm very, very happy about it. And it's it's basically a pavilion based on COVID with the mass cremations that we were having. And so New York City Parks they're going to be hosting it. So I'm super excited. So everyone can actually go and visit it, and, you get to experience this space. And it really talks about, again, energies and, us as people. So like, how that gets translated into buildings, etc. So I'm super excited about this. So you guys are the first one who knows. So thank you.
Congratulations. That's so exciting.
Great stuff. Well, thanks, Bev. Everyone, if you must depart, we understand. Thank you for a fantastic 2021. We've got lots of great stuff lined up in 2022. So happy holidays to you and your family. Got a few more questions for Satpal. So if, again, as you said, take care, everyone. And Satpal, we've got a question from Eric. Eric, over to you.
Oh, sorry. I was actually, hi, Sean. I was actually asking a question about, it was in the link about a product called Aero Shield.
Gotcha.
Oh, that's me.
Yes.
No
Sorry
worries.
about that.
Hey, you know what? I just want to hear your voice. You're always on these shows once in a while. And usually have some really fantastic questions. Today was an easy one. So there you go.
Yeah, no.
South Paul, you should look into it for the windows, because I mean, you would still need to replace the windows, but there must be machinery to make those windows, right? You're talking about the depth problem to get them triple glazed. Aero Shield is like, do you remember Aerogel, you guys? Like
yes.
So it's a clear version of that. It's an insert that can be done. So you don't have to change the machinery for making the windows. You can insert it in the same space. It'll give you triple glazed performance. It's not quite commercialized, but it's close, very close.
That's cool.
I think it's great for historic windows, right? Like we have a ton of mill buildings in Massachusetts and they're using historic tax credits. So even to get double glazed is like a huge thing for those enormous openings, right? So if we could get those put in, the windows that are approved for historic, if we could get those in, like that would be huge. It wouldn't be so hard to electrify, right?
No, I think you're right, actually. And I think that's the reason, even because I don't think these will be standard windows to begin with. I think definitely it would have to be something that's a marriage between the old and the new, for sure. It would have to be its known prototype for that project, I feel. But there's so many of them, so it makes sense. It's fine.
Okay. Well, I'm sure there's other. They must like do a standard. There's a company who does this, right? Like, or maybe it's changed over time. I don't know.
It's a very different world. It's a very different world. Once I actually entered it, even I was surprised how much airtight ways and strategies they have come up to, which is pretty much what we're implementing anyway. Just going around the entire structure for the new ships, they do that. Even yachts are a good example of this, and you're pretty much in the water most of the time in a yacht. They have all this, but I think it's just there's not many of them, which at least this one would be docked, so it wouldn't be moving. But at least when they're moving, I don't think they are really hitting the net zero numbers per se. And I think they're trying to, it's it's a harder, I think that typology is like a harder one to work with, and it's literally it's metal, and there's a lot of thermal bridging, but I would say it's not impossible. It's a lifelong passion project. So
Thanks, Eric, and thanks, Beth, for your comments. I just want to go back up to Brian's. I know Brian left, but he had an interesting thing. And when you're looking at designing this, did you actually look at the outside temperatures of the ocean? So if you're traveling in different parts, how that would affect the envelope?
No, I mean, yes, you do, because it's not on land. So obviously when you're based on, when you're even obviously docked on, it will be different. Like, there'll be wind, like, that would be your main thing. And something for the reinventing the lifeboats itself, it's kind of a different animal, just because I guess one way of kind of looking at it for me, my head was something similar to like, when you have the tree houses and you're so high up in the sky, and there's so many things moving in different directions, and what is the warmth, like how do you design for that? So I think a lot of it was going back to then non-traditional, like obviously traditional to some degree, but looking at things that we use in our everyday life, being it cars, being it, the way we travel in planes, like looking at their technologies instead, because they are the ones who are already so high up in the sky, like, and they're already like looked at very different ways. And just this whole, to me, was a very steep, interesting learning curve. And I learned so much in that short period of time, how the planes and cars and everything else is constructed in comparison to buildings. And it was truly exciting. So I think my approach was looking at anything that was moving. Like if I know how it's moving, I know how they're trying to keep the air and the comfort in, that kind of made me understand the space, because I guess in my mind, it was more relatable, if that helps.
Very insightful. Again, such a very interesting project. And again, I think a lot of us can't wait for you to see the next phase and how this develops. So
I'm excited about this too.
Shannon just popped in with a question. So Shannon, over to you.
Thanks, Sean. Satpal, you mentioned the Intrepid might be following suit with a renovation. Did I get that right?
No, the Intrepid is
design team.
No. So the Intrepid is basically a ship that's already docked in New York. Right. And it basically has a lot of old ships, like, from the World War. They just sit on it. It's just there. But if you look at the Intrepid, if you Google it, you will see with the Intrepid, like a lot of the systems, by that I mean like the mechanical or the other stuff, it has its separate little small building. And you can see that on the pier. And it just kind of connects to that. So you'll see these huge like wires, not wires, but like conduits, which are attaching. It's almost like a plug thing. And sometimes people don't pay attention to it because they're too busy looking at the ship, but it's there. You can't miss it, actually.
Yeah, I'm familiar with it. And I knew they had done a renovation when they made upgrades to the museum. And I thought maybe they were making more, and you were going to find your way on the design team.
I would love to be part of that. I don't, if you know someone who can tell them that I need to be there, I would appreciate it.
Yeah, likewise. If you make your way on, you just give me a call. My father actually was stationed on the Intrepid. So.
Oh, wow. Yeah.
Well, yeah, I hope you get another boat. I would love to see this become kind of a typology.
I would love that too. I mean, a lot of the work I guess that I'm doing right now is more on typology, system thinking, but yeah, I have a feeling they would embrace it. It's just RXR this is something they have invested in, and RXR is a huge developer. So I hope, and this is something they really, really want to put together very soon. It's just that COVID happened, and I don't know what their next steps might be. So hopefully in the future, there's many of us with many great ideas. I'm sure we will be writing them with more good ideas.
Would you do anything differently if you went back and started over? Was there anything that you decided on as a team that once you got down a certain leg of the path that you couldn't go back?
I think the biggest thing would be, I mean, I think because my thinking is more like systems with design. I would love just to really kind of make it more like a technology, but that's just my approach. I feel it would be great for what it was serving in the past to kind of take that same life, like really be completely smart, completely, you know, off the grid and all the other fun stuff. I think that would be like really pushing it. And I think it's harder when you're working with a ship of this sort, because I think the enclosure it's not the same everywhere, which I learned. And I think one of the things, if I look back, which I would definitely do, is kind of probably look at it in a more, the same way of looking at the light bulbs as the series of like planes or cars, maybe approaching that kind of use in the internal retrofit, just because I feel it might just save time, if not anything else. But it might lead to different technologies just for this particular retrofit, if that makes sense. Like maybe like a new type of prototype thinking can be kind of come about that's for these type of ships, which is thermally broken. You know, you kind of looking at it in a much more holistic way, where you know where it hits like the moisture level, where it needs to be like at its sweet spot of like, you know, no dew point, etc. I think that would be great, but I think that would pretty much would mean that you're visiting at every different sections, and that but that technology now exists, and I think that's pretty much what I would do differently if I was to go back to it this time. I would probably say let's use modern technology.
I can't imagine how many therm models there were on this, but the lifeboats were absolutely beautiful. I would stay in one of those, and I heard Zach saying the same thing. Very cool.
I'm sure everyone would love to be in them. In fact, I think for me personally, it was the lifeboats and the outside promenade space, which was really special, mainly because I get to be weird with them. So I enjoy that. So I think it's cool. But it's not everyone's cup of, I mean, I feel once you get the envelope of the main hull working, it's pretty much like any envelope, it will work. You know, it's great. It's just like making sure it's compartmentalized, you get all the systems working, you test it. And when you're above a certain level, you can afford to be then a bit more experimental. But I think with a lot of things I'm learning is, even if it's a crazy idea presented to a client, the worst they can ever say is it's not something they want, or but I think having a compelling story helps. And the same way I showed it to you guys, I pretty much showed it to them in sense of breaking down why the structure could work in our advantage. And they were really excited about it. And I think just kind of using the ship in that way, that was something everyone was blown away with. And it was really a starting point, which is really exciting for me.
Thank you so much for sharing it with us tonight.
Thank you.
It's a nice bon voyage to 2021.
That is true.
Well played.
Yeah.
Thank you.
And Sepal, did you have conversations with new designers working on, you know, these new mega ships for the U.S. Navy and what they're trying to do to incorporate, you know, a high performance shell?
We didn't actually. The main people that we had conversations with Gibbs and Cops, who are the main designers of this particular ship, and they're still very much involved in this ship actually. And they still continue to do ship architecture, marine architecture. What they were telling me, and which is through them actually that I learned the way we were designing, it was not that different in terms of high performance. They were already having these continuous mineral wool insulation that was going all the way up. They were staggering it. They had actually thermally broken like a lot of like the brackets, etc. So, but I think their main, the thing that they're hitting against, I guess a lot of people, is how do you reduce the loads for something so huge? And I think that's one of the things that they're trying to do right now, from what I'm understanding. And it's when you're placed on a deck, I think it's much more easier than when you're moving. But I think they're investing in a lot of different technologies out there to put it like to see what might work. But I'm not quite sure. And of course, Navy being the Navy, they're not going to share a lot of their technologies with me. So, and I get that. So that's all I know is like what I've seen so far. It's exciting. What they're going to do in the future, I hope it's going to be everyone else feels too. But if we have loads of ships, sitting in, just sitting there, I think all of us should just maybe try to make it a home or something. So we have some kind of backup as sea level rises. So
Yes, all boats will rise to the top. So, well, I think we've got all the questions. Sorry, I missed this last one. No, there's not, just a comment from Scott. Well, everyone.
I have one question, if I
Sure,
may.
Devin, fire away.
Awesome. Thank you so much. Super wonderful. Really happy. Thank you. Regarding the ships and the thermal bridging of the ship in the hull and the sorry, the temperature differential between the interior and exterior being relatively constant, exterior being variable, presumably above freezing water temperature. Were there any things that you might think would be, hopeful or excited or challenging regarding this? As ships move through, like really warm water to close to freezing water, below freezing, it's not so good for a ship.
I think they have this whole that convective loop thing that happens just because of the way this particular ship is designed. It has such the double hull. They have a lot of this kind of convective loop that happens. I think to really.
Is that right?
Sorry?
It's double hull steel.
It's a double hull skin. Yeah, it's a double hull skin. This particular ship is a double hull skin. And this is the reason we could run a lot of the systems, at least from sea deck onwards. And then you come back down. But this ship itself is basically two sets of plates which curve and makes the shape it makes.
Double hull steel ship, right? It's steel, right?
Actually, it's not just only steel. They have another material in it, which I learned. So it's not just only steel.
What's the vintage of this ship?
Sorry?
Original build? What's the vintage of original build of the hull of the ship?
When was it originally built?
Yeah.
I want to say it's in, let me just quickly look that up so I don't tell you the wrong year. I want to say it's obviously served the Second World War.
Mostly steel then. In that interstitial space, it's just air, right? It's meant to be non.
Yeah, it's just air. In the past, they've had like things like rocks and etc. put into it to balance it out, but it's just mostly air.
Can you put stuff in there like aerogel?
Yeah, I mean, honestly, at this point, if you're going to try and make it pretty airtight and just perform, I think you could do pretty much anything.
That original double hull steel hull, if I'm not mistaken, was for security. So the first hull is damaged by.
Yes, you're right. Yes, it was for that reason. Yes.
Like, not think.
Yes. If they ever hit anything, you're protected with the second one.
Like an aerogel, some high performance.
Yep.
Nanogel of some sort. Awesome. Super great. Thanks so much.
Thanks, Devin.
Yeah, thank you I forgot to mention that to people. The reason it had the double skin was really for protection.
Yeah.
So you guys know now.
Well, I think we've all watched the movie Titanic to realize the importance of the double hull.
Yeah, that's true.
Well, everyone, let's wrap things up for tonight and for the year. It truly is a pleasure. Zach and the rest of the Accelerator team, I am always thankful for all the hard work that you guys do to get this show organized. Always happy with our Tuesday night crew. I'm so blessed to be able to find you guys topics. There's so many great projects in the pipeline. It's great to connect with everyone. Thank you for all the work you're doing to grow and accelerate the Passivhaus movement. So from everyone here, and maybe I'll let Zach actually have the final word, but from me and the rest of us on the crew here, thank you so much for joining every week. please keep continuing doing what you're doing so we can showcase your beautiful work in 2023. Happy holidays, everyone. Zach.
Thank you.
Thank you, Sean. It would not be the same without you. And so a big thank you right back at you, man. I really appreciate it. None of this would be happening without you, in fact. So, and Paul, this is really wonderful. Really appreciate the great, and it's like a breath of fresh air kind of project to close out the year with. It's so different. I don't think that's the right metaphor given that it's on the sea, but whatever. I guess we're swimming and Bev, thank you for being the host. This is great. So everyone, yeah, absolutely. Have a great holiday and we will see you in January.